Hello everyone. Now I am going to explain you about a basic construction and operation of an arithmetic circuit. So what do you mean by arithmetic circuit? A circuit which can perform the arithmetic operations like addition, subtraction, increment, decrement. Okay. So for that operation, now here we are designing a one circuit and we are going to explain the basic operation of that circuit. Okay. So here first of all here if we want to perform any arithmetic operations, right, we need to take down to some two register information. So here let us assume register A, the first register as register A, which is a 4-bit length, and here one more register, register B. Here let us assume the register B bit information as 0010. So here if I want to perform any arithmetic operations on two registers, okay, so here I am designing a one circuit, that circuit which can perform addition of the two numbers, subtraction of the two numbers, or by considering a one register we can add one to it, like incrementing the number or decreasing a one number from it or decrementing that operation. So now we are going to perform all that four operations by using a one circuit. So a circuit which can perform all arithmetic operations is called as an arithmetic circuit. So here I am considering some two register information which are of 4-bit length. So therefore register A is coded as 4-bit length, which are bits are A0, A1, A2, A3. Similarly register B as B0, B1, B2 and B3. So if I want to perform addition operation or subtraction operation on two binary numbers, here I have to apply the operations on A0 bit as well as B0 bit. So therefore here likewise we have 4 bits of information. So therefore to perform some operations on these 2 bits, here we have to consider one circuit that is called as a full adder. So therefore here we have 4 bits of information. So therefore here we need a 4 full adder circuits. Okay. And after that here we have different types of operations like addition, subtraction, increment or decrement. Okay. So therefore here at a time here I want to perform either it may be a addition operation or subtraction or increment or decrement. So here what I am doing here, based upon my selections I am going to perform one particular operation. So therefore here I am giving some selection lines named it as S0 and S1, which is going to give a 4 selection lines. Okay, so 0 0 0 1 1 0 1 1. So based upon these selection lines it can perform either addition or subtraction or increment or decrement. So therefore here so we are taking a one circuit which works on these two selection lines and works on multiple input lines, gives only one output. So therefore that circuit is called as a multiplexer which can works for multiple inputs based upon the selection lines and gives only a one output. So here we have 4 bit of information, so we require 4 multiplexers. Okay, so by using a full adder circuits and multiplexers we are designing an arithmetic circuit. So see here, so this is a 4 full adder circuits and 4 multiplexer circuits. Now we are going to connect this one by one. So as we know that the full adder circuit, which is a circuit, it can works with the 2 operands and one previous carry. So here I am taking a for each bit of information I am connecting a one full adder circuit. So here for this full adder the A bits are directly connected to full adder as a input and carry in is connected to full adder. So as we know that the full adder has 2 operands A bit and B bit with a one previous carry and which will result in a sum and carry out. So coming to this B bit information is taken from the multiplexers because here either it is going to give some data. So by using that data, the data will be added or subtracted or incremented or decremented. So here I am taking a multiplexer output. I am connecting that multiplexer output to a full adder input. So therefore this full adder has 2 inputs. One A bit is directly from the A bit data and B bit data is from the multiplexer output and with a previous carry. So therefore the full adder has two operands and one with a previous carry going to results in a sum and carry out. Okay, so this carry out again input for a next higher order full adder. So therefore here next higher order full adder is, so let us assume this is full adder of 0 bit. So similarly full adder for first bit, so it can accept the input from first bit of register A, first bit of or output of the multiplexer 1. So let us assume it is a B1 output. So therefore this full adder has a A1 as input, B1 as input, which is from output of a multiplexer, and previous carry as a C1 as input. So again based upon these three inputs it is going to give a sum and carry out. Again this carry out again input for a next higher order full adder which has the inputs of A2, B2 and C2, results in sum and carry out or C3. So therefore again it is connected to A3, B3, C3, sum and carry out. Okay, so here the for full adder A bit information is directly connected from the A bit information, B bit is connected from the multiplexer output. So here we are taking a multiplexers which can works with the two selection lines. So therefore here I am taking a two selection lines, naming it as S1 and S0. So here I want to connect these selection lines to each multiplexer. So draw a line which is going to connected to all S1 and S0 pins. So here check out here now. So S1 is connected to 0th bit of multiplexer. Sorry, S1 and S0 is connected to multiplexer 0. So S1 is cross mark here, S0 is cross mark. So cross indicates there is a connection between these multiplexer and the selection lines. Similarly coming to the first multiplexer, so S1 is connected, S0 is connected. Similarly for multiplexer 2, S1 and S0 is connected. Similarly for multiplexer 3, S1 and S0 are connected. Then here, so here the selection lines are to, we have four possible combinations. So what are they? 0, 1, 2, 3. So write down all these possible combinations of each multiplexer. So multiplexer 0 has four data combinations like 0, 1, 2, 3. Multiplexer 1 has two selection lines, four data input combinations, four data input combinations, four data input combinations, which will result in only one output, one output, one output, one output. Okay, so here now we are going to connect this data inputs. Okay, so here already A bits are directly connected to full adder. Now here we have to get the output of multiplexer that is connected to full adder. So here what I am doing here, I am giving a selection lines as 0, 0. Here I am giving a carry as 0. Okay, so therefore here first of all I am explaining this first is mux 0 output. So here for 0th bit, here I am connecting a B0 bit information. So here the 0 bit is connected to B0 bit information. Similarly mux 1 0 bit is connected to B1 bit. Mux 2 0 bit is connected to B2. Mux 3 0 bit is connected to B3. So here if the selection lines are 0, 0, so the 0 bit is selected as a output and it is transferred to output here. So what is output here? So if the selection lines are 0, 0, 0 bit is selected. For 0 bit we connected here B0. So this B0 as output connected as input here. So the full adder output is what? Here we are getting full adder as A0 plus B0 plus, here the carry is 0, Cin is 0. So what is the operation is done? This is simply A0 and B0. So similarly here for A1 plus B1 with some carry C1. So similarly here it is A2 plus B2 plus C2. Similarly here A3 plus B3 plus C3. Okay, so therefore here we are getting an operation. So output is D is equal to A plus B plus. So here carry is 0, right? So if carry is 0, it is simply A plus B. So what is the operation we are getting? We are getting an addition operation. Okay, so similarly if carry is in is equal to 1. So here if carry in is equal to 1, here we are getting a full adder inputs as A0, selection lines as 0, 0, right? So if the 0, 0 means what? The 0 bit is selected, the 0 bit is connected to B dot, that is connected as output, and this output is connected to input for full adder. So therefore here the output is A0 plus B0 plus 1. Similarly A1 plus B1 plus 1. So likewise here we are getting a output D is equal to A plus B plus 1. So what is this operation? It's simply an addition operation. So if the selection lines are 0 0, we are getting a addition operation. Okay, so similarly now we are checking for another operation. So to get the another operation, here I am changing the selection lines as 0 1. So if the selection lines are 0 1, that case we consider with the carry in 0, carry in as 1. So this is the second case. So here if the selection lines are 0 1, the first bit is selected. So here for the first bit, here I am going to connect a one NOT gate which is connected to B NOT bit. So therefore here what is the bit here? B NOT bar. Similarly for first multiplexer it is B1 bar, B2 bar, B3 bar. So here if the selection lines are 0 1 with a carry in 0, okay, so therefore here we are getting a output as B0 bar. So the final output is A0 plus B0 plus carry is 0 here. So similarly these are A1 plus B1 plus carry. Sorry, this is B0 bar, right? Okay. So similarly A2 bit, similar D2 bit is A2 plus B2 bar plus carry. So therefore here we are getting a output D as A bit plus B bar plus the carry as 0. So here we are getting a output. Okay. So the register A information B bit is 1's complement. So here we can say it as subtraction with borrow. So similarly if the selection lines are 0 1 with a carry and as 1. So if the selection lines are 0 1 with a carry 1, again 0 1 means first bit is selected. So what is the first bit? It is simply B0 bar. So therefore the final output is A0 plus B0 bar plus 1. So what is this one? So it indicates that it is a subtraction operation. So how we are saying it is a subtraction operation? Because this is a one register information, the second register is complemented and one is added. So 1's complement plus 1 means what? 2's complement of subtrahend is added to minuend is nothing but a subtraction operation. So if the selection lines are 0 1 with a 0 or 0 1 with a 1, so here we are getting a subtraction operation. So this is about the subtraction operation. Okay, so similarly here we are next we have to increment the operations. How we have to increment it? So here if I want to increment 1, so here we have to take down a 1 register. Okay, the second register will be 0, so then only we can say the here. So here if suppose if register A is 1, if register A information is there, if 1 is added to it, then only we can say A is incremented, or if A minus 1 means A is decremented. So there is no need of another register. So here what I have to do, we have to make the another register information as 0. So here I am connecting a some second bit. Okay, that second bit to logic 0. So if the selection lines are 1 0, so here if the selection lines are 1 0, the second bit is selected of each multiplexer and the second bit is connected to where here logic 0. So therefore here what is the output we will get here? Logic 0. So therefore the final output is what? The full adder output is A0 plus B0 bit is 0. Logic 0 is selected and with the carry is equal to 0 ones and 1 is 1. So see here. So if the selection lines are 1 0 with the carry 0, here we are getting output as A plus B information is 0 and carry is also 0. So therefore it indicates the transfer of A. If suppose carry is equal to 1, D is equal to what? A plus B bit information is 0 and plus 1. So what it indicates? It simply indicates that A is incremented. So here if the selection lines are 1 0 with the carry 1, then A is incremented. Or if the selection lines are 1 0 with the carry 0, A information is transferred to D bit. Okay. So similarly here if the information is incremented, then we can decrement that. So how can we decrement that? We have to simply subtract one value from the register A. So to subtract some value here, what we are doing? Here we are adding a one value to a third bit. So how it is already for second bit we are connecting it to logic 0. For that logic 0, here I am connecting a one NOT gate. So here it will give the what is the value here? This is simply logic 1. So this logic 1 is connected to max all the third bit of each multiplexer. So therefore here if the selection lines are 1 1 with a carry 0 or carry 1. So if the selection lines are 1 1, third bit is selected. Here third bit output as 1. So here what is the output we will get? Here the output is simply A0 plus B bit input as 1 plus carry is equal to 0 or A0 plus 1 plus 1. So what it indicates here? It simply indicates here D is equal to A of 1 with the carry 0. So it indicates that simply A is decremented. So how A is decremented? It is simply nothing but A minus 1. So here if we take some register R3, so what is the subtraction process? R1 minus R2. So how can we write this information? Simply R1 plus the complement of R2 and 1 is added to it. The 2's complement of subtrahend and is added to minute, then it will called as a subtraction operation. So similarly here what is the information we are getting? A bit plus 1 plus 0. Okay, so let us assume that it is a register R1 information and here let us assume it is a 0 bit. So 0 bit is complement is 1. Okay, or let us assume it is a 1 bit of information. So here 1's complement is 0 and 1 is added to it. So here this is a register R1 information is A and the 1's complement of 1 is 0 and 1 is added to it. So 1's complement of 1 is 0 and 1 is added to it. So this operation is simply 2's complement of 1. So 2's complement of 1 is nothing but this is a subtrahend value. We can indicate that with a minus 1. So therefore here the register A information is A. So therefore this operation is simply a minus 1 operation. Nothing but A is decremented. So therefore here we can say if the selection lines are 1 1 with 0, A is decremented. And similarly in the final operation is 1 1 with a carry 1. So therefore if it is 1 1, third bit is selected. So what is the third bit? 1 is selected here. So therefore here what is the final output? That is simply D is equal to A plus 1 plus 1. Okay, so therefore here how can we write it as this A plus 1 as A minus 1 plus 1? It will simply get cancelled. So what you are getting? We are simply A. So transfer of A. So here, with the based upon the selection line, if the selection lines are 0 0, okay, we are getting an addition operation, 0 1 subtraction operation, 1 0 with a carry 1 increment operation, 1 0 with a 1 1 with a carry 1, or 1 1 with a carry 0, we are getting a decrement operation. So a circuit which can perform all these operations is known as an arithmetic circuit. Thank you.